In this question it says, suppose a powerful battery is connected between a pair of inert graphite electrodes and dipped into a pot of molten aluminum oxide, Al2O3. The battery makes a current of electrons flow in the direction shown by the arrows in the sketch. So essentially we have aluminum oxide being formed into aluminum metal and oxygen gas, which could be useful, right? Aluminum oxide is the stuff you could find in sandpaper. Aluminum metal is found in aluminum foil, so these have very different properties, and for some metals this is how they're industrially made. So we need to identify several things. First thing we need to identify is the anode and the cathode. So the anode is where oxidation is occurring and electrons are lost, so electrons are flowing out. So A is the anode because electrons are flowing out. B is the cathode because electrons are flowing in. We now need to find the half reactions that are occurring here. But before we do that, we can answer this question. Which electrode is the cathode? Well, the cathode is B because electrons are flowing in. At the cathode, reduction is occurring. And if we're going to form a metal, a salt back into its metals into its metal and non-metal as elements by electrolysis, then the reduction is going to occur for the metal. So essentially what we have is we have Al3 plus as a liquid going to Al with no charge as a liquid. Well, if we want to do that, we need to add 3 electrons. So reduction is going to occur because the metal is positively charged, and we have to add electrons to form the Al3 plus is positively charged, so we have to add 3 electrons to form the metal. So that's basically what we have going on here. At the anode, we're dealing with the non-metal, and oxidation is occurring. So in this case, we have oxygen, which has a 2- charge as a liquid, and we're going to form it into O2, elemental oxygen, as a gas. One thing that we need to notice is that we need 2 of these O2 minuses, and when we do this we have to lose a total of 4 electrons. For each oxygen we lose 2 electrons, and then we form O2, so we lose a total of 4 electrons, like so. So in the next question it says, write the balanced equation for the half reaction that takes place at electrode A. Well, electrode A is the anode where oxidation occurs, so this is the half reaction that takes place at electrode A. The final thing it says is write a balanced equation for the overall reaction. So now we need to find the overall reaction. And what you should notice quickly is that there's an electron mismatch, right? The electrons have to even out and cancel out for the overall reaction. So we need to make these balance. Well, it turns out between 3 and 4, the lowest common denominator is 12. So we need to multiply everything in the top equation by 4 in order to make 12 electrons. And in the bottom reaction, we need to multiply everything by 3. So 2 becomes 6, 1 becomes 3, and 4 becomes 12. Now we can add the reactions together. To do that, we add everything on the reactant side on the reactant side, everything on the product side on the product side, and then cancel out anything that's on both sides. So here we have 4 Al3 plus liquid plus 12 electrons plus 6 O2 minus liquid yields 4 aluminum liquid plus 3 O2 gas plus 12 electrons. And in this particular case, the only thing that's common on both sides is the 12 electrons that we needed to cancel out. So we cancel them out. 4 Al3 plus liquid plus 6 O2 minus liquid yields 4 Al liquid plus 3 O2 gas. And now we have the overall reaction. So there are several steps involved here, but this is the overall reaction. This, before we multiplied by 3, was the half reaction at the anode, and then the anode and the cathode we identified right at the beginning of the question.